Hello everyone, this is Jay from BTYT Tech Library. Today we are going to build an interactive website in Kotlin with Ktor and Thymeleaf templates. Thymeleaf is a modern server-side Java template engine for both web and standalone environment. What is template engine? We can check more details on Apache FreeMarker's introduction page, another Java template engine. It's a library to generate text output based on templates and changing data. Usually, a general-purpose programming language like Java is used to prepare the data. Then a template engine like Apache FreeMarker or Thymeleaf displays that prepared data using templates. So in the template, we can focus on how to present the data, and outside the template, we can focus on what data to present. This approach is often referred to as the model view controller pattern and is particularly popular for dynamic web pages. It helps in separating web pages designers from developers. Okay, then why server-side rendering? SSR has several merits. For examples, simplicity to maintain a single code base, security to prevent placing data or code onto the browser that could provide insight to attackers, and faster load times. Another thing is search engine optimization and social media optimization. Indexing SSR sites is much easier for search engine than CSR sites. And you can get a nice preview when you share the web page's content via social media. The merits of SSR? Well, the name speaks for itself. It puts the burden of rendering contents on servers. Now you know what a template engine is and why we need it. In this session, we will transform our former Task Manager project into a web application. Are you ready? Let's code along. Navigate to the Ktor project generator. In the project artifact field, enter com.btyt.ktor-task-web-app as the project name. And add the three plugins: routing, static content, and Thymeleaf. Click the download button and open the Ktor project. We can reuse some codes from our previous session. Navigate to source main Kotlin BTYT and create a subpackage called model. And inside the model package, let's bring the task.kt file from our task manager session. At that time, we added handwritten extension functions to convert tasks into HTML. But in this time, we are going to create a server page that can write the contents of tasks to the browser. Go to the template.kt file within the plugins package. In the configure templating method, add a route for /tasks as following. When a request is made for the /tasks endpoint, the server creates a list of tasks and then sends it to the template called all-tasks that will be used on the page. This template requires two things: the name of the template to use, all-tasks, and a table of values, the list of tasks that should be visible on the page. When setting up the Thymeleaf plugin at the beginning of this method, Ktor looks for server pages in the templates/Thymeleaf folder within the resources directory. Similar to static files, it expects this folder to be inside the resources directory and for its contents to have a .html extension. In this case, the file named all-tasks.html will be correspond to a template called all-tasks. Let's say we got the all-tasks.html file from the design team. Normally, the design team sends us an HTML file filled with sample values. So we need to move the file into the source main resources template Thymeleaf folder and make the Thymeleaf modification. Thymeleaf comes with something called the standard dialect that define a set of features which should be more than enough for most scenarios. We can identify when these standard dialects are being used in a template because it will contain attributes starting with the th prefix. Let's check some standard expression syntax together. For variable expressions, it uses a $sign followed by a curly bracket. Wait, Kotlin, is that you? And we will find them as HTML attribute values or as a part of them. Also, we can find variable expressions in scenarios which more complex processing like conditionals, iteration, etc. For example, tasks inside a $sign curly bracket selects the variable called tasks from the context and evaluates it as an iterable to be used at a th:/each loop. When we run the app and access localhost port 8080/tasks in the browser, we should see all current tasks displayed in a table. Okay, now let's add some get routes. Because we included a static content plugin, the following code will be present in the routing.kt file. This means that, for example, a request to /static/index.html will be served contents from the source/main/resources/static/index.html. Open the file and replace its contents with the following implementation. Each form section will match the corresponding get routes. Get tasks by priority, by name, and create a task. On top of the file, we got the hyperlink to get all the tasks. When we run the app and access localhost port 8080/static/index.html in the browser, we can see a link button and 3 HTML forms that allows us to view, filter, and create tasks. Note that when we are filtering tasks by name or priority, we are submitting an HTML form through a GET request. This means that the parameters will be added to the query string after the URL. For example, if we search for tasks of medium priority, this is the request that will be sent to the server. This index page will be entry point of the client side. Next, let's work on the model part. The repository for tasks can remain identical to the one from the previous session. So let's import task repository.kt file into the model package. Okay, we have an entry point and model. So let's implement business logic. Controller. Navigate to the templating.kt file in source main Kotlin BTYT plugins. Replace the current version of configure templating function with the implementation from the previous task manager sessions, then make some modifications. Most of the part remains the same, but we need to change parsing the value from path variable to query parameter, and make the response with the Thymeleaf view rendered with data. In a GET request to /tasks, the server retrieves all tasks from the repository and uses the all-tasks template to generate the next view sent to the browser. In a GET request to /tasks/by-name, the server retrieves the parameter name from the query string, finds the matching tasks, and uses the single-tasks template to generate the next view sent to the browser. In a GET request to /tasks/by-priority, the server retrieves the parameter priority from the query string, finds the matching tasks, and uses the tasks-by-priority template to generate the next view sent to the browser. To finish the job, let's work on the Vue part, Thymeleaf template. Continue following our scenario. We are going to modify the handed over sample HTML file to work as a template engine. Go to source/main/resources/templates/Thymeleaf folder and import the single-tasks.html file we hypothetically got from the design team and make the Thymeleafication. Add the Thymeleaf XML namespace in the HTML tag and replace the sample data with variable expressions. For tasks-by-priority.html file, use iteration expressions. If we run the app and access localhost port 8080/static/index.html in the browser, we can check view all the tasks, view tasks by priority, view or task by name work as expected. Good. Now let's add a post request handler to /tasks. The logic is almost identical from our previous session. The only difference is making the response with Thymeleaf template. Awesome. We've successfully rebuilt our task manager as a web application and are now familiar with using Thymeleaf templates. In our next session, get ready to dive into an exciting new topic, WebSockets. This powerful technology is widely adopted and generates immense interest, but can be challenging to implement effectively. We will explore its capabilities and discuss how to harness them in our project.